Module 1, Topic 3, Test Review. All right, as you can see pretty clearly, number one, we're doing counterexamples to prove that each statement is not true. So I just gave some counterexamples here. Obviously, ostriches cannot fly, which disproves that all birds can fly. All numbers divisible by 3 are odd is untrue because 6 is divisible by 3 and it's an even number. All numbers are either even or odd. That's untrue because 0.65 is neither even nor odd. Okay, didn't expect that. All right, number 2 asks you to sketch at least 2 spherical lines and explain what makes them spherical lines. So I'm sorry I wrote in cursive, but there it is. All right, so both highlighted circles share a center with the sphere, so they all have the same center. This makes them both great circles, and great circles are considered to be lines in spherical geometry. So there you go. I just went ahead and used the great circle that was already there. I just highlighted it. All right, for number 3, we're going to write each postulate and give an example. Oh, I didn't give an example. Let me do that. All right, so there's the postulate, and an example could be if this were 60, I know how to add. Okay, sorry, this were 120 degrees, and this were 60 degrees, then those would add up to 180. All right, for the segment addition postulate, we have this right here. So as an example, let's say that was 7, and let's say the whole thing was 20. Then we could use the postulate to figure out the measure of BC. So that would be 7 plus BC, which is unknown, equals 20. And then if we subtract 7 from both sides, then we would see that BC equals 13. So that would be a nice example. And then for part C, angle addition postulate, oh, I don't know. Let's say that this is 95 degrees and this is 10 degrees. So that would be ABD is 95 degrees. And if you added that to DBC, which would be 10 degrees, then the whole angle is 105 degrees. So that would be an example for angle addition postulate. All right, number 4, given the information that triangle OPK is congruent to triangle RFD, write congruency statements for all the sides and angles. So you can either draw the triangles and go from there, or you can just set up the congruency statement vertically like this, and that would, well, you can just look at it honestly. But if you want to stack it vertically, you can easily see that O and R go together, P and F are corresponding, and K and D are corresponding, or they go together. So OP and RF are congruent sides, and we know this because the triangles are congruent. And then PK and FD are congruent, and then OK and RD are congruent. And the same thing for the angles here. You can see that, that, and that. All right. Number 5, explain the difference between a theorem and a postulate. A theorem is a statement that can be proved true by like logic, definition, stuff like that. A postulate is just a statement that's assumed to be true. Number 6, looking at these triangles below, what information would be needed to prove they are congruent with the side theorem? And I'm going to get rid of that. Sorry. Okay, so 2 sides on each triangle are already congruent to each other, or to the other triangle sides. So we just needed the third side, which would be BC and HJ, to prove SSS. Now for SAS, we need a little bit more. Oh, I'm sorry, ASA, excuse me. So we already have, we can use this side. For example, if we use this side, then we would need to prove that Angle A is congruent to angle E, right there. And that C is congruent to J. Oh, I put J. Okay. And then if we use this side, then we would have to prove that A is congruent to E, right there, and that B is congruent to J, right there. Okay. Oh, wait, I was right the first time. I was like, wait, I was right the first time. So let me go over this one again. So if we use this side, then we would need to prove that A is congruent to E and that C is congruent to H. Sorry about that. So we could do either or. So I included both. What information would be needed to prove the triangles are congruent with side angle side? So for side angle side, again, we have a side. We need the included angle, which would in this case be A and E. Number 7, determine if these triangles are congruent, and if so, identify the congruence theorem that proves it. Don't forget to list the evidence. So off the bat, we see that we have a side that's congruent in both. We have another side that's congruent in both, and then we have an angle that's congruent in both. I'm going to say that again. A side, and an angle. This angle is not included. Included meaning for the two sides that are marked congruent, the included angle would have to be between those sides. So 30 degrees is not. And that's what I showed down here. Okay, so this angle is not included. That means this is an SSA situation, which doesn't disqualify these from being congruent, but it's not enough information to prove beyond a shadow of a doubt that they're congruent. And let me explain why real quick. I put a little example over here so y'all can see. Okay, so here's an example of why angle, side-side angle doesn't work. So let's say we have these two triangles. This angle in both triangles is congruent. So I'm split this over here so you can see those angles are congruent. So that would be angle. And then these sides are congruent. Let me put it back, baby. Let me put it back so y'all can see. Matches right up. And then this side and this side are congruent. Okay, I can't really, hold on. I'm gonna prove it. Cause I know some of y'all are like, no, it's not. The left one's longer. It's not. I measured it myself. I'm gonna try to line it up. Dang it. Hold on a little bit more that way. Okay, see? They're the same size. So as you can see very clearly, this theorem does not prove congruence because these triangles are not congruent, but they both have a side, and a non-included angle congruent, okay? So that is why this is not enough information. Okay, same situation over here. And if I look at this triangle first, you see we have side, because that's a shared side, right? That's the reflexive property, and angle. So again, that's side angle. Even if I look at this one over here, you'll see the same thing, side, and this angle over here, not included. So that is, again, not enough information to prove that those two are congruent. All right, determine if triangle MAT is congruent to MHT. If so, blah, blah, blah. All right, go. This one's pretty obvious, I would hope. MA should have been congruent to MH, but it's not. Instead, it's congruent to its sister side. The side is on the same triangle. That doesn't help us prove that these two triangles are congruent. And in fact, they're not congruent because these sides are different and these sides are different. So it's not congruent at all. We have enough information to determine that. And then for number 10, this one is congruent by side, as you can clearly see here. Okay, and we see that MP is congruent to itself by the reflexive property. Don't forget that. All right, number 11. Okay. I'm gonna try to walk you through this. So I started by listing the side, the angle, and the side information. So the first sides that I used were A, B, and D, E, and as you can see, they're both 3, which proves that they are congruent to each other. Secondly, I used angle A and angle D. So here's what I went through. We know that this slope, the slope of AB is undefined. The slope of AE is 0, which means these lines are perpendicular, which means that's a 90-degree angle. And that's what I explained over here. I'm going to say it again. This is undefined. This is 0 slope, which means they are perpendicular because those are negative reciprocals. And that's 90 degrees because they are perpendicular. And that's all of what I outlined over here, just to prove that angle A and angle D are congruent. They're both 90 degrees. And then lastly, this side and this side are congruent. They're both 7. So these angles, these triangles are congruent by side angle side. And for the next one, I did pretty much the same thing, same process. So for the first side, I went with QR and YX, and they are both equal to 12. So both of those sides are congruent. And then for the angles, okay, I had to get a little creative with this. So we know that this is a 0 slope. So I indicated that here, and then this is also a 0 slope. I indicated that there. I use that to kind of prove that these aren't congruent angles because as you can see here, this slope is 0, but this slope is -4. This slope is 0, and if this slope were also -4, those angles would be congruent, but it's not. It's -2. So since these are not congruent, but these, I'm sorry, since those slopes are not equal, but these slopes are equal, we can ascertain that those angles are not congruent. So angle RQS is not congruent to angle YXZ. All right. And then this side here and this side here are not congruent. And I proved that using the distance formula. So these are not congruent triangles. I didn't bother writing that they're not congruent by SAS because they're just not congruent at all. So I just felt like that would be redundant. All right, so for this one, same process. For the first side, I used JH and LM, which honestly, we could have stopped right there because those sides are not congruent. And if those sides are not congruent, then of course it's not congruent by side, side, side. But I went ahead and did the rest of them anyway. GH and LK are both 5, so they're congruent. JG and MK were not congruent, as you can see here. So, yeah. All right, for this one, I mean, of course, these triangles are going to be congruent. We're performing an isometry. It's a rigid motion, so it's not going to change the size of the triangles. Um, so yeah, but anyways, there's the work. You can see it. I just used distance formula on this one because, you know, it's a diagonal line. And for number 15, according to CPCTC, which, okay, if you forgot, CPCTC stands for corresponding parts of, sorry, the of is unimportant, congruent triangles are congruent. All right, I know that's a lot, but that's what it is. So there's your C, your P, your C, your T, your C. Basically, it's just saying if two triangles are congruent, then the parts that go together are equal. That's it. We went over this when we first started this topic. So I just went ahead and drew two triangles. I drew them at random. I didn't know if this was supposed to be obtuse or not. It doesn't matter. Just draw two identical triangles, label them accordingly, making sure that M and G are in the same spot, that they're corresponding. Make sure N and R are corresponding, and make sure K and E are corresponding as well. And then just plug in the given information where it goes. And you can see here G is 73, N is 3x minus 5, and K is 4x. And then you're going to use the CPCTC reasoning, right? So if these two triangles are congruent, that means M and G are both 73 degrees. So if this is also 73 degrees, then you can assume that if you add these three angles together, it's going to equal 180. So that's how I set up my equation. Then I just solve the equation. Combine your like terms. Boom, boom. That's how we get the 7x. 73 minus 5 is 68. I subtracted 68 from both sides. That's how I got that next step. Then I divided both sides by 7. That's how I got this last step. And then after that, because it asked me to find a measure of angle K, I had to plug it in for angle K. But I didn't stop there because I like to verify that my answer is correct. So what I did was I plugged it in for angle N, and then I added all three of those angles together to make sure that I really got 180. And I did because I'm smooth like that. And so 64 degrees was correct for angle K. Again, I know that these angles don't match the type of triangle that I drew. It doesn't matter. Oh, my bad. It does not matter. I'm just trying to get an idea of what's going on. Okay, number 16. So for this one, Jonesy says that these two triangles, I'm sorry, these two sides are congruent. I went ahead and drew these separately because there's a lot happening. So those two sides are congruent, and that angle N and W are congruent. I'm not really sure where Jonesy got that from because nothing is marked on this figure to indicate that is the case. Therefore, the two triangles are congruent by ASA. So, um, yeah. Anyway, is Jonesy correct? Well, if we can assume that this was a question that Jonesy was presented with, and that this person assumed these two were congruent, this was not secret information that Jonesy had, then no, Jonesy was not correct. So what I did again was drew these separately based on the given information. These two triangles are congruent, but they're congruent by SAS, not ASA, because look at the pictures. This is 8. Y'all know how I got that 8, right? Just 5 plus 3. And then the same thing over here. So anyways, this is 8 and this is 8. So that's our side. This is congruent to this because of the reflexive property. Angle B is congruent to itself. And then the 5 and the 5 are congruent. So this right here, boom. Yeah. So, I mean, yeah. Yeah. And I said this already, but angle N and angle W can only be proven. I'm sorry, angle N being congruent to angle W can only be proven by CPCTC after the triangles are deemed congruent by SAS. So we can't assume that they're congruent until we prove that the triangles are congruent. All right. Hope that was clear as mud. Peace.